Alright guys, here's my second video on related rates. Remember that your homework for today is to watch this video and follow along. I am going to be solving two problems with you, and the problems that we're going to do in class tomorrow will be similar to or use similar skills to what you're going to be learning today. Remember that I'm going to be using your completion of the video as your homework grade. Even if you don't get all of the answers correct, that's okay, but you do need to watch the video. Before we start, I've kind of listed the steps for solving a related problem up at the top of your paper, so feel free to refer to that as we are going on. Now, one thing, because I only have this much space on my screen, I might have to start a new screen every time as I'm solving the problem. So make sure you are writing things down. If you miss anything that I've written down, you can always go back in the video so that you can catch up on what you've missed. All right, so let's start our first problem. Okay, practice 1. Let D be the length of a diagonal of a rectangle whose sides have the lengths x and y, and assume that x and y vary with time. If x increases at a constant rate of 1/2 feet per second and y decreases at a constant rate of 1/4 feet per second, how fast is the size of the diagonal changing when x equals 3 feet and y equals 4 feet? So, our first step is to draw a picture, and I know that the shape we're looking for is a rectangle. So let me draw a rectangle. This rectangle has the lengths x and y, and it says it has a diagonal. So D is the length of the diagonal, and if you remember, a diagonal is a line that goes from one vertex to the opposite vertex. Now, all the other numbers that I'm given look like they are either rates, which is something that's changing, or I know that x and y are changing. So those are all numbers that are changing, so I'm not going to label them on my picture. I'm going to list them in my given and find numbers. Second step is to write an equation, which I think I can do fairly easily because I can see that it's a Pythagorean theorem. I know that it's a rectangle, so it's a right triangle right there. So my equation is going to be d squared equals x squared plus y squared. Okay. Third step is to write what I'm given and what I have to find. So let's do that. Given. I can see that x is increasing at a rate, so that already tells me that I've got dx over dt, which equals 1/2 feet per second, and then y decreases at a constant rate again, so I know that's dy over dt equals 1/4 feet per second. Now, one thing that's really important that we haven't really looked at before, x is increasing, which means that x is getting bigger. However, y is decreasing at this rate, which means that actually the length of y is getting smaller, and the rate of y is going to now be negative. Okay, so if something is getting smaller, the rate is going to be negative. Now, what I want to find is how fast is the size of the diagonal changing? So I'm seeing the word how fast, and I'm seeing the word changing. So I know that I'm looking for, ooh, this is a weird one. It looks weird. It says dd. But I'm going to find dd over dt. And I know the units for that, I'm going to write that down so I don't make a mistake, is going to be feet per second. And I know that that's when x equals 3 and y equals 4. So hopefully you have more space on your paper than I do. I'm going to start a new page so I can solve the problem. Alright, so I just have a little bit more space on my screen, and we're starting with d squared equals x squared plus y squared. My next step is to take the derivative with respect to time. So I've got 2d times dd over dt, right? Remember that we're using the chain rule, and so that's why I have a 2d to x times dx over dt plus 2y times dy over dt. Okay, so now I'm going to substitute the numbers that I know. Do I know d? I don't know d, right? That seems like a problem because now I feel like I don't know d and I don't know dt over dt. So let me leave that blank for now, but I do know that x equals 3, dx over dt is 1/2, y is 4, and dy over dt is negative 1 over 4. So I know that. Now, I'm trying to find dd over dt, and since we're not always looking for two things, I know that I should be able to figure out d from the problem. Now, is there any way to figure out d from the information that we know? Well, let's go back to our original equation. We know that d squared equals x squared plus y squared, so if d squared equals 3 squared plus 4 squared, and you solve that, you will find actually that d equals 5. So I'm going to actually substitute that in. If you have a question about that, I can explain that in class tomorrow. So I have this equation. Now, once I simplify this, I'm going to let you guys kind of figure that out. My answer is going to be that dd over dt equals 1 over 10 feet per second. Now, something really important, I can tell that dd over dt is positive, which means that the diagonal is increasing and not decreasing. So last but not least, our important step is to write the answer as a full sentence. So the length of the diagonal is increasing excuse me. Sorry, there's a G in there. Increasing at a rate of 1 over 10 feet per second. That's my answer.